There's a moment in physics where reality stops behaving. Not because experiments fail, not because the math breaks, but because the math keeps working, and it takes you somewhere you didn't expect to go. If you follow Einstein's equations far enough, you don't just get gravity, you get black holes, you get white holes, you get wormholes, you get parallel universes, and none of it was science fiction, it fell out of the math. The first strange thing, imagine someone falling toward a black hole. From your perspective, they slow down. Their movements stretch. Their clock ticks slower. Right at the edge, the event horizon, they don't disappear. They freeze. The light from them fades, redder, dimmer, until it vanishes. To you, nothing ever enters a black hole, but that's not what they experience. For them, they cross the horizon without noticing anything special. No wall, no barrier, no sign. Two observers, two realities, both correct. That's when you realize something is wrong, or deeper than wrong. Newton's problem. Newton gave us gravity as a force. Mass pulls on mass. But even Newton didn't like his own theory. How can something pull on something else across empty space? Across nothing? Einstein fixed that. Gravity isn't a force, it's geometry. Mass bends space-time. Planets follow the curves. Light follows the curves. Time follows the curves. Space-time tells matter how to move. Matter tells space-time how to curve. And that relationship fits into one deceptively simple equation. One line. But inside it, a family of coupled differential equations so complex that solving them is like untangling reality itself. The first solution. Einstein couldn't solve them exactly, but in 1916 a physicist named Schwarzschild did, in the middle of World War I, from the front lines. He imagined the simplest possible universe, one spherical mass, no rotation, no charge, nothing else. And when he solved Einstein's equations, two singularities appeared, one at the center and one at a specific distance from it. At that second boundary, later called the Schwarzschild radius, something extreme happens. The escape velocity becomes the speed of light. Inside that boundary, nothing escapes, not even light. That's the moment black holes were born. Not from telescopes, from math. But it gets stranger. At first, scientists thought this boundary was a physical singularity, a real edge, a wall. But later they realized something unsettling. The singularity at the event horizon was a coordinate illusion. Change the coordinates. The singularity disappears. The boundary isn't a wall, it's just a place where space falls inward faster than light can climb out. To an outside observer, you never see anything fall in. To the person falling, you cross smoothly. Both views are valid, that's relativity. Reality depends on your frame. The map that breaks your brain physicists built space-time diagrams to understand this. When you compress infinite space and time into a single map, something extraordinary appears. On one side, a black hole. On the opposite side, a mirror structure, a white hole. Instead of swallowing everything, it ejects everything. Nothing can enter. Everything must exit. It's the time-reversed twin of a black hole. And that's not speculation. That's mathematics. If Einstein's equations allow black holes, they also allow white holes, because the equations don't care which direction time flows. Flip time. The solution still works. And then it gets dangerous. Extend the map further. Push the solution to its limits. You don't just get a black hole and white hole. You get two universes connected through a bridge in space-time, an Einstein-Rosen bridge, a wormhole, a tunnel linking two separate regions of reality, two separate universes, from one clean, elegant solution. The simplest black hole solution already contains a black hole, a white hole, a wormhole, and a parallel universe, all hidden in the geometry. That's what happens when you follow Einstein's math without fear. But wait, there's a catch. That solution describes an eternal black hole, one that always existed, not one formed by collapsing stars. In the real universe, black holes form from dying stars. And when you account for formation, the white hole disappears. The wormhole collapses too fast to cross. The parallel universe becomes unreachable. Reality trims the excess, but not completely, because then someone solved Einstein's equations again. This time, for a rotating black hole. Rotating changes everything. Every real star spins, so every real black hole spins. And the rotating solution, discovered decades later, is far more extreme. Now the singularity isn't a point, it's a ring. And inside that ring, the geometry opens again. More regions, more possible universes, more bridges. In theory, you could fall into a rotating black hole, avoid the singularity, and emerge somewhere else. Another universe, another space-time, another reality. Mathematically, it's allowed. Physically, that's where things collapse. The inner horizon problem. Deep inside rotating black holes, energy piles up infinitely. Light compresses, instabilities explode. Most physicists suspect this destroys the passage. The inner horizon likely becomes a true singularity, sealing off the exotic regions, closing the door. But here's the uncomfortable truth. Black holes themselves were once considered impossible. Now we've photographed them. We've heard them collide. We know they exist. So when the math says something strange, history tells us not to dismiss it too quickly. The final question. White holes probably don't exist. Traversable wormholes likely require exotic matter we've never observed. Parallel universes hidden in black hole geometry may be mathematical artifacts. But here's what we can't ignore. Einstein's equations are over 100 years old. They predicted black holes before we believed them. They predicted gravitational waves before we detected them. They predicted time dilation before we measured it. So when those same equations whisper, there could be more, we listen, because sometimes the universe isn't limited by imagination. It's limited by how far we're willing to follow the math. And if one day someone does fall into a rotating black hole, we won't need courage, we'll need coordinates. Because if Einstein was right, reality is much larger than the part we can see. If you want more deep physics that bends your sense of reality, subscribe to Xpress-curiosity, because the strangest things in the universe don't come from speculation. They come from equations, and equations don't lie. They just take you somewhere strange.